Welcome back to Algebra 1. This is lesson 4-9 about area problems. Now, I want to start with what I would call macro organizers. This is sort of the big picture for doing area problems, okay? Because these are the general ideas that you're going to use for most of these area problems. For most of them, you're going to have, and sometimes it's a square swimming or a rectangular swimming pool. Sometimes it's a poster or a picture with a frame. Sometimes it's a garden, and you've got a walkway around the outside. There are a lot of different contexts, different stories to go with the area problems. But the logic of most of them is going to be the following. You've got a large rectangle, or it might be a square, it might be a circle actually sometimes, but most of them will be rectangles. You've got a large rectangle, so here's our large blue rectangle. And then inside it, you have a smaller rectangle, the red rectangle, okay? And most of these problems are going to deal in some way with the difference in area between the large blue rectangle and the nested, the inside smaller red rectangle. Now, I hope you can see that if I were to take the red rectangle here and I were to superimpose it right here, meaning put it on top of, right there, that the area that's going to be left showing is what I've shaded in black up there. The area that's left, or you can imagine taking a scissors, cutting out the red rectangle in the middle, and what's left is going to be just the border, the black rectangle there, or the black border that's colored. So most of these problems are going to have something to do with taking the area of the large rectangle, and usually it's going to be subtracting the area of the smaller rectangle, and they'll give you what is left over, i.e. the border is what's going to be left over. They'll give you some number out here. Right? Now there may be some variations on that, but that's sort of the general idea of these problems. Okay? So now we're going to work two of them, problem 2 and problem 4, on page 173. Okay, we're going to do number 2 and number 4 as representative of these kind of problems. So let me erase really quickly here. Okay, and let's see. Okay, if these problems are like what I've just described. So number 2 says, a rectangle, so we've got a rectangle, is twice as long as it is wide. That's the first sentence. Take your rectangle. Okay, draw a rectangle. Okay, it's twice as long as it is wide. Okay, so if we use W to represent our width, how wide it is, 2W would be how long it is. It's twice as long as it is wide. That's sentence number 1. Now, we'll read the next sentence. Okay, if both its dimensions, so both its length and its width, are increased by 4 meters. Okay, so how do we increase it? That means we're going to have a bigger rectangle around the outside, right? So the first thing I'm going to do, just to make this a little easier, is I'm going to move my variables inside there, just to kind of get them out of the way so the picture is clearer. Okay? Now, I have another rectangle on the outside because it says I'm going to increase both the width and the length. Okay? And the problem tells me that I'm increasing the length and the width. It says both its dimensions are increased by 4 meters. So I add 4 meters to this dimension and 4 meters to this dimension. Now, to keep it balanced so that it's got a nice even border, if I increase this length here by 4 meters, okay, to keep it symmetric, that means that I'm going to put 2 meters here and 2 meters here. So the length of this side down here, right, is going to be from here to here. From here to here is 2W. Okay? And from here to here, this is 2 meters. This is another 2 meters here. So that's increased my length by 4 meters, 2 on each side. Okay? Now, then my width, I want to increase my width. So that means I'm going to increase here by 2 meters and increase up here by 2 meters. Okay? Let me also put my W over there, and we'll stick the 2W up there just to keep it consistent. Now, how long is this side then going to be? Well, just from here to right here, in between, right here, this distance is W, right here, from here to here. Okay, W. So I could write it this way. Okay? And then from here to here is 2. And from here to here is 2, because we were told it's increased by 4. So my width of my original rectangle is increased by 4. Okay? Now what I recommend you do, because human brains deal better with less clutter, okay? We actually have kind of 2 pictures crunched together there. So what I recommend you do is, and I use different colors because it helps me keep things separated. I have a big red rectangle, okay, and I have a smaller blue rectangle in the middle. Okay? And I'm going to write the dimensions over here on my separated figures. So the blue one's easy. I look and say, okay, this is 2W here, and this is W here. Okay? Now, then I have to look at my red rectangle. Well, what's the area, or what's the length of my red rectangle? Well, it's 2 plus 2W plus another 2. 2 plus 2 gives me 4. So the length of my red rectangle is the 2W plus the 4 that it was increased. And the width is the W plus 2 plus 2. W plus 2 plus 2 is W plus 4. Okay? Now I have the dimensions, the length and the width, in variable form of both of my rectangles. Now what I want to do is find the area of each of them. So I usually write it in the middle. I write area equals length times width. Here's length, 2W plus 4. Here's width, W plus 4. Length times width. Okay? Then over here, same thing. Length is 2W and width is W. Okay? Now, then we'll go back and let's read and see what else the problem says. It says, okay, if the dimensions are both increased by 80 or by 4 meters, the area is increased by 88 meters. Okay, well, the increase in area, if this was my original rectangle, the area, i.e., if I were looking at covering this in contact paper, right, I'd buy an original amount that would cover the middle, and the increase, the additional contact paper, okay, or paint if you want to think about painting it, the additional that I would have to buy would be to cover essentially the border, right? Because this area in the middle is increased by the amount that we added around the outside, okay? So, and what we're told in the problem is that the black area around the outside is equal to 88 square meters, okay? And the black area, like we just said a minute ago, the black area is the difference between the area here and the area here. Because if I took a scissors and I cut away the area in the middle, what I would be left with is just the black border, the black area. Okay? So we're told that the whole area minus the smaller area is equal to 88. That's what our problem says so far. So now we have it all set up. It says make a sketch. We've done that. Find the dimensions of the original rectangle. Okay? So now we have an equation that we have to solve. So we're going to come up here and say, all right, 2w plus 4 times w plus 4 minus 2w times w. So area of the red rectangle minus area of the blue rectangle equals the black area that's left, which we're told by the book is 88. Okay, now we have to FOIL. So first we get 2w squared. Outer, I'm drawing a face. There's the guy's chin. 8w, because it's a plus here. Plus, here's the guy's mouth, 4w. Then we got to close up his head so he doesn't bleed to death there. There's the last terms. Plus 16. Minus 2w times w, 2w squared equals 88. Now, we have two of these walrusy kind of animals here, and two of them here that we're taking away. So we can simplify. That gives us a 0 there. And then we have 8 walruses and 4 walruses, or 8 W's and 4 W's. That's 12 W's plus 16, okay, equals 88. Take away 16 first. 12W equals, let's see, what do we get, 72 here? And W is going to be, when we divide by 12, W is 6. So there's our answer. Now, we should always go back and check. Okay? So let's put in a 6 for W everywhere. Here's a 6. Here's a 6. 6. Okay, now let's see if this actually works. So 2 times 6, that means that our blue triangle, or our blue rectangle here is going to be 2 times 6, or 12 meters long and 6 meters wide. So its area is going to be 12 times 6, or 72. Okay. Now the larger one says that each side was increased by 4. So 6 plus 4, that means that its width is going to be 10. And 12 plus 4, that means that this width is going to be 16. Okay? So 10 times 16, the area here is going to be 160. 160 minus 72. Let's see, 160 minus 72. We have to borrow. And we get, 88, which is what we were supposed to get. Okay? That's how you do area problems. I think we'll leave number 4 for another day.
Alrighty.